Hey guys, so I'm doing this video as a thorough walkthrough for the Patreons of Crush Depth. So thank you guys for supporting Crush Depth, and I'm going to do a walkthrough of my little car. So as far as I know, this is the world's first electric vehicle traction battery powered high voltage audio system. First and foremost, we have this high voltage line that is tapped into the power inverter, which is this big guy right here. So the power inverter takes the 400 volt battery and it does two things. One, it sends power to the traction motor, and two, it creates power for the 12 volt subsystem. So I tapped into it at the high voltage side, so that's 400 volts coming through. When I'm ready to play the system, I turn on that big breaker right there, and the power goes all the way to the back of the car, comes out through these lines over here, positive and negative, and we're going to loop through these big breakers over here. So we have redundancy in the breakers, and all the electricity eventually routes through. We have a big relay here, appropriately rated on the positive, and another big relay on the negative. So by default, even though these will be on, there's no power flowing through this big 400 volt amplifier. The idea is that this is all controlled by a custom system I'll jump into, and there's a bunch of extra stuff I'll jump into. But first of all, let's take a look inside the car. So that high voltage sound system is actually going to be powering these guys. These are a 12-inch FI Audio SP4 V2 Plus. They can each take about 7 to 10,000 watts RMS, and that's for prolonged periods of time. However, for shorter bursts, they could take a little bit more, so that's why we have such a big amplifier feeding them. The box itself is fully reinforced. Those ribs over there, as you can see, they're angle iron, very, very stiff. And this box here is 3 layers in the front of 3/4 inch wood and 3 layers in the back. So we're talking about that much thickness. It's all tied into the car. And then we've got a brace here that braces the top roof. Otherwise, without this brace, I've actually cracked many windshields. So this brace prevents the windshield and the roof from flexing too much. It still flexes, but it does help it quite a bit. On the inside, we have 2 8-inch speakers back here for the mids, and then a 6.5 plus a tweeter. And then we have a 3.5 and a tweeter. So the whole sound stage comes out about right here. It's very nice and even. Got a little temperature monitor, little voltage monitor, even though mostly I rely on the app. I'll show you guys. And when it's all running, I also have this guy plugged in. It's an OBD2 port that plugs into the car, and all the data is actually being sent to this unit, the control unit. So I'll talk a little bit about that. So here we have the 8-channel that are feeding all of the speakers and mids on the inside. This is run off of the 12 volt subsystem in the car. However, when we get to all this other stuff, it's completely isolated. So we have a battery, a 12 volt battery that runs for this guy, and this 12 volt battery that runs some of the systems, and they're all isolated differently, including the low pass filter. So we have the radio RCA coming in here, and the goal is we actually want to split the signal. That way all of the 12 volt control system for this guy and the high voltage are completely isolated from the 12 volt subsystem of the car. So if anything does happen, we don't fry the car. And the way we achieve that is we have an isolator unit here So you could see this guy runs off the car's 12 volts, RCA comes in, so the radio is tied to the same ground and same power. But once the signal gets to this guy, this isolator, we basically use induction to create an RCA signal that goes into the amplifier that's completely separated from the car's stereo. So if something happens to this guy, there's no feedback into the 12 volt system of the car. Same thing here. You'll see we have some one-way diodes. These diodes help the 12 volt subsystem of the car charge this bank. However, if this bank was to have an issue over voltage, etc., it would not feed back into the car. These diodes prevent that from happening. I believe they're like 10 amp diodes, so I have 4 of them. 40 amps can go into this lithium battery, but cannot go back out to the car. So this battery is charged by the 12 volt sound system, subsystem of the car. However, it now powers all of this components. So what do we have here? We've got the Raspberry Pi with the main bus coming in, going through a bunch of different fuses that are doing different things. So the Raspberry Pi has voltage divider boards, and it's sensing basically the voltage on the input side of the high voltage, sensing the voltage of this battery pack, sensing the remote voltage, and a few other things. And also with Bluetooth integration, like I mentioned, it's tied into the Bluetooth OBD2 port coming in from the car, so it's sensing what the car is thinking it's doing, and then what it actually sees via all these different voltage points. Next, depending on whether or not I want to run the system, either via a Bluetooth app or a simple switch over here, we give a command to the software, and the software does a bunch of things. So we have these relays, like I mentioned, including some of these. And the idea is that before the amp is pre-charged, what we do is we actually turn one of these relays on. It's a thermistor, and the thermistor allows the 400 volts to slowly flow into this amplifier over about 500 milliseconds. Without that, what would happen is as soon as you turn the power on, you have 400 volts of electricity all rushing into these components, possibly damaging all the different fragile components, such as the big capacitors in the amp. So we want to prevent that. So the software intelligently slowly turns up the thermistor, monitors the voltage. And once the voltage is stabilized over about half a second, 500 milliseconds or so, then the bigger relays turn on, the big relay. When those turn on, we charge all of these big capacitor, and I actually have other ones that are going in here that are going to be for even higher frequency. They're faster capacitors for smoothing out the ripple. Reason for that is the car is very noisy. The 400 volt bus is noisy because you have the motor. The motor acts both as a traction motor, it's 3-phase, and a generator. So it's constantly sucking, generating electricity, and it's all a bunch of ripple. So this helps stabilize the 400 volt bus to get clean audio out of this big amplifier. Then you have a bunch of smaller micro relay controllers. And the reason we have those is because the Raspberry Pi is digital. So what we want to do is turn the digital signals into things that we can control via, again, the 12 volt bus. And then same thing here, this divider board I built basically turns an analog input signal into a digital signal the Pi can read. So that's how it knows the voltage across the board for all these components. We have the thermistor control, we have the main control, and then here we're going to have a secondary control for the capacitors. So we could turn these things on and off individually and independently. It gives us a lot more control and safety. Again, a lot of this is built for safety and have some sort of automation built in. If anything is detected out of line, I do have the program that's basically scanning at about 3000 hertz. That can turn off most of the components relatively quickly. However, it's still dangerous because you have a lot of power stored up in those guys. So once the system is on, usually I'm very far away from the back, and this is a danger zone, as you can see. Finally, the audio output goes into here, and it's all parallel. So the subwoofers get their power in parallel. Each one gets an equal amount of power. This amplifier is rated at 112,000 watts RMS, and running that at 400 volts I did range quite high because I actually blew up the fuse in the car. It's a 350 amp fuse tied into the main battery bank of the car, and I did blow that. So if we do the math, that's 350 times 400. You could do the math and see just exactly how many watts this amplifier can drain from the battery. So it's a legit number when it says over 100,000 watts RMS. You probably won't see this anywhere else. Again, it's very unsafe. It's, as far as I know, the first person that has tied into the electric car battery, 400 volts at 68 amp hours, I believe, on the Fiat. That's a lot of power here. Really unsafe. Hope you guys enjoyed it. Thank you again for becoming patrons on Crush Depth. Hopefully you guys enjoyed this content.